In this video, I'm going to show you that the weight of an object can, at least for most of this course, be computed from a different property called the mass. What the mass actually means will be introduced later in the course. For now, we only need to be able to use the mass of an object to calculate the weight. So I'm going to start by introducing you to the unit we use for the mass. So the unit of mass that we use in this course is called the kilogram, or kg for short. If we were sitting together in a classroom, I would pass around some 1 kilogram objects so that you could get a feel for what that is. But for now, I'll tell you a 1 kilogram object near the Earth's surface weighs about 2.2 pounds, which is about the size of a small melon. I should actually say a very small melon. Medium-sized melons, maybe 2 or 3 kilograms. Okay, so anyways, as I said, what we need to be able to do with the mass of an object is to use the mass of the object to calculate that object's weight. So let's say we have here an object with a mass of m, so m for mass. And let's say the object is near the Earth's surface. So if we have an object of mass m, which is near the Earth's surface, then we can use that to calculate the magnitude of the gravitational force acting on the object. The magnitude of the gravitational force acting on an object of mass m near the Earth's surface is the mass times something called the free fall acceleration, which we denote little g. So that little g that I used in that formula there is called the free fall acceleration. It has a numerical value of 9.8 meters per second squared. All right, so if I take this expression from before, I can write that as an equation now. I can say that the gravitational force, or rather the magnitude of the gravitational force on an object of mass m near the Earth's surface is the mass times the free fall acceleration. Now, this equation here implies a relation between the unit of force, the unit of mass, and the unit of the free fall acceleration. The unit of the gravitational force is Newton, because it's a force. The unit of mass is kilograms, as I just mentioned over here. And the unit of the free fall acceleration is meters per second squared. So this tells us that a Newton is equal to a kilogram times meters per second squared. So let me box that. We're going to be using that quite a bit, and I suppose this should be boxed as well. Okay, so let's just do a quickie example with this. Very quick example here. Let's say that I have an object with a mass of 2 kilograms. I want to know what is the weight of the object. Okay, so here's what we do. The weight is the magnitude of the gravitational force, so I'm going to draw in the gravitational force vector. It has magnitude mg, and then we can say magnitude of gravitational force vector equals the mass times the free fall acceleration. The mass is 2 kilograms. The free fall acceleration is 9.8 meters per second squared. 2 times 9.8 is 19.6. And then we have, well, let's write it out, kilograms times meters per second squared. And what's a kilogram times meter per second squared? I just showed you that that's the same as a Newton. So the magnitude of the gravitational force on this object would be 19.6 newtons. Okay, in the next video, we will use this idea to do a much more substantial example.